welcome back from the break. I'm glad that you're joining me again for the session. In our previous session, we looked at hydrolysis of salts, and this session we're going to use to explain in terms of an example. When we have sodium hydroxide and it's titrated against ethanoic acid, I just want to remind you that this ethanoic acid is the same as saying acetic acid. Okay, so we have sodium hydroxide and acetic acid, and they ask us to write down a balanced chemical equation for the titration of the reaction. Now, firstly, you must remember you need to know this, or you need to know your ionic table and to know how to write your formulae. And then you also need to know that what part of your acid will become your salt and what part of your base will become your salt. And then you will have to balance it because we've asked for a balanced chemical equation. We have the balanced chemical equation here where we have sodium hydroxide and ethanoic acid to form sodium ethanoate and water. Sodium ethanoate is my salt here, and we can also call it sodium acetate. Okay, right, and then as it is now, the reaction is balanced. Now the question here is, which indicator will be used for this specific reaction? Now, before you can make a choice on your indicator, you need to know what's reacting with what. So firstly, you need to know that sodium hydroxide is a strong base and ethanoic acid is a weak acid. Now, when you just look at the two, you can see that the base being the stronger one, we know, in genetics we know that if we have a strong trait, the strong trait will always go and show, whereas your not so strong or your recessive trait will then be underlying. So coming back to acids and bases here, if it's a strong base, then I can tell you now we will have a weak basic solution that will form here. So you will go look at your specific reactant that's strong, and you look at the characteristic of the weak one, and you combine the characteristic, the word strong to the characteristic of the weak one, and you know that your reaction will be, in this case, this will be a weak basic salt. We can also look at it on the pH scale. If I have 7 more or less there, strong base will be there, and your weak acid will be just lower than pH of 7. If these two start to neutralize each other, we will have a salt that will be a little bit over a pH of 7, which means a weak basic salt. When we go look at the weak basic salt, we know that a weak basic salt will have a pH in the range of, a bit bigger than 7, so 8,3. So in this case, we will have a strong base and a weak acid reacting with each other in the presence of the indicator phenolphthalein. So which indicator would you select? We said that we will use phenolphthalein, but we always need to answer why that specific indicator. When we go answer specifically what indicator, we need to say that the indicator comes from the fact that we were using a strong base and a weak acid. Right. Explain your choice of that indicator, as I said. So you need to talk about the fact that it's a strong base and a weak acid that's reacting. Right, so explain in terms of your reaction in front of you. You can now go look at, if you have water that breaks up into hydrogen ions and hydroxide ions, and you look at sodium acetate that breaks up into acetate ions and sodium ions, remember this is a weak acid, then you know that the acid of this strong base to the likes of sodium and the ions from the water to the likes of hydroxide ion, this 2 here will not leave the ionic state. They will try to remain ionic because it's strong base, and there will be no stress on the water part of this reaction. But let's go on. When we look at the acetate ion and the hydrogen ion or the proton there, these ions come from weak acid, and this weak acid here will always try to remain in molecule form and not in ionic form. So this hydrogen ion and the acetate ion will now react, and it will shift the equilibrium to the left, and it will form a molecule, which means that we will have a low Ka value there. So what's the stress on the equilibrium of the water? The stress of the equilibrium of the water will actually now, this hydrogen there will actually combine there, which means that causes a stress on this equilibrium position. Right, but if we now go use our methodology to go look at what the stress is and what the response is, let's quickly go look. We now know if this hydrogen and the acetate ion reacts to form sodium acetate, it actually means that there will now be a decrease in the concentration of hydrogen ions. What will the system do? According to Le Chatelier, the system will try to respond to this by making more hydrogen ions to increase the hydrogen ion concentration. And if that happens, it means that my forward reaction will then be favored. And if the forward reaction is favored to make more hydrogen, it will also make more OH minuses in the solution. And that increase of my hydroxide ions will actually mean that I have a pH that's a bit bigger than 7. So your sodium ethanoate is a weak basic salt. Now we ask you to sketch a curve of the pH of the reaction solution, where we will look now at the sodium hydroxide that's titrated against the ethanoic acid. Firstly, we need to also go show the endpoint there. So if we look at our axis here, we will have to say, in this case, we have the ethanoic acid in the burette, and we have the sodium hydroxide is in the burette, and the ethanoic acid is in my flask. So over time, we will look at the pH, and we should know that we have a pH, not maybe there, a pH more or less there for ethanoic acid, and we have a pH there for our hydroxide because it's a strong acid. And then this is more or less how our curve will look here. And if we go look at our endpoint should be midway of the point where we have a parallel line to the vertical axis. So we will have our endpoint more or less there. And what does that endpoint mean? That endpoint means that the salt that's resulting from a strong base and a weak acid is weakly acidic. Let's see. That is how it looks. We have an endpoint that's a weakly basic. Sorry, I said weakly acidic, but it's weakly basic, meaning the pH is bigger than 7. Right. So if we summarize what we've dealt with today, we said that titrations are a chemical technique or method used to determine the equivalence point of a neutralization reaction. We also know that neutralization reaction is an acid and a base reacting with each other to form a salt and water. So salts may undergo hydrolysis and change the pH of a solution. I just need to remind you one way to easily remember this. I always say strong acid, strong base, neutralize, forms a pH of 7. Strong acid, weak base, neutralize, and because the acid is stronger, the trait of the acid will remain in the salt. So it's a weak salt. Strong base, weak acid. Because the base is the strong trait here, it will form a weak basic solution. And that for me today, that is me, and this is where I will end our session today. I hope you've learned something, and I hope you will be able to use it. Please go well. See you next time.